Okay, so now is the time to understand or to see the examples where the graph of function is not a straight line. Okay, last time I gave you the idea that when you talk about a function of the type y is equal to some ax plus b, where a and b are real numbers. So just try to get the idea, just try to recall that if I write a function of the type y is equal to ax plus b, where both a and b are real numbers, then the graph of this is always a straight line. And then in case of straight line, we know that means if I get one point over here and if I get one point over here of a straight line, then there is a unique line that passes through it. So whenever such type of functions are there, then drawing their graphs is not a difficult task. You can easily think about it, something like this. Just try to get some idea. It may be something like this. Or suppose your one point is over here and second point is over here, right? So can we draw the line passing through that? Yes, with some efforts, some little efforts, we will be in a position to draw that line. Okay, let me try my best. Yes, you can see that I have got a line passing through these two. But what happens is that in general, means when you change the nature of this function, for example, even if you consider y is equal to x square, it's not very difficult actually to understand, to get the idea. But the graph of this is also not a straight line. So what we can do whenever I want to draw this type of graph, the idea is something like this, that you consider several points. That will give you general idea about the nature of the graph, and then you try to join these points by a smooth curve. So if I put x equal to 0, I get y equal to 0, so 0 comma 0 point is over here. If I put x equal to 1, 1 square is 1, so that you are going to get 1 comma 1 point over here. Similarly, if I put x equal to minus 1, then I will get minus 1 square is also 1, so minus 1 comma 1. Put x equal to 2, you get y equal to 4. Put x equal to minus 2, again you get y equal to 4. And then in between, say 1.5, put x equal to 1.5 and so on. So that way if you put, then you will get such type of points. I am trying to give you a rough idea about this, and then that these points will tell you, give you some idea that okay, it seems that the graph of this is somewhat like this. I'm just giving you the idea. So what we will do now, let us try to get that on the graph paper. Okay, and in fact from this also you can understand something. See that square of a number is never negative. So ये जो आपका ग्राफ है y equal to x square, it will never lie below x axis, it will be always above x axis. So let us try to get that. Since I have some idea about the graph, let me just take it over here. Okay, fine. And now I am putting that y is equal to x square. And now you can see that this is the graph of y is equal to x square. And then whatever those points that we were talking about, see, you can get those points also. So for example, 0 comma 0, then minus 1 square is plus 1, minus 2 square is 4, minus 3 square is 9, and similarly 1 comma 1, 2 comma 4, 3 comma 9, and so on. So means what we can do is that we can also get those points if needed. Okay, fine. So now you can see that these were the points. Actually on this I was trying to show, so these were the points. You may have some more points also. So if you don't want that graph, let me just let me make it completely white so it won't be visible. Fine, but then you are getting these points. If you want some more points, say for example 1.5, what is the square of 1.15? 2.25. Similarly you get minus 1.5, take its square, it's 2, again plus 2.25. So now you can see that you are getting some more points. So that way you will get several points. Say for example 2.1, then its square is 4.41, and similarly minus 2.1, and its square is again 4.41. So yes, so you can see that okay, fine, I am getting something like this, and then if you want, you can actually draw the graph. Yes, so this is the graph of it. Fine. Let us take some more examples. Okay. Yeah. So instead of y equal to x square, I will make a small change and I will say y equal to x cube. Okay. How is y equal to x cube? Process is same. You try to get several points. Okay. And then you join them by a smooth curve. Okay. So everything depends now on your skills, drawing skills. For the time being, we are going to do all this thing. Again 0 comma 0 point would be there, 1 comma 1, 2 comma 8, 3 comma 27. That is how you are going to get. Once again you will get these points between 0 and 1 if you situate these points. Now you may feel that it is looking like that earlier curve only, but when you go to the negative side, minus 1 cube is minus 1. So आप यहाँ पे आ जाओगे फिर, something like this. So your graph, the nature of the graph would be like this. And then if you join this by a smooth curve, so that smooth curve would be somewhat like this. Is how you are going to get the curve or the graph of y is equal to x cube. Okay, once again on the graph paper I would like to give you the idea. Let us go for fresh graph paper. Okay, so as I say, let us first of all try to get some points. So 0 comma 0, then 1 comma 1, then 1.1 and its cube is 1.331. Just try to recall that. Then 1.2, what is the cube of 12? 1.728, right? Then 1.3, what is the cube of that? 2.197. Okay, this is how I remember. Then 2 cube is 8. Okay, and then what I will do, I will take the minus negative of this. All negatives I will get over here. So minus 1, minus 1, minus 1.1, minus 1. Fine, so let us try to situate those points. Okay, you can see that you are getting these points. Of course 2 or 3 means between the 2 and 3 also you can get those points. You find their cubes and so on. So you are getting this type of graph over there. So if I actually insert that function x cube, okay, let me use black color or something like that. See that what kind of graph I am getting. It is like this. So it's not a straight line, okay, as one can see. It's a curve, and if you want to get the idea of the curve, the only thing that right now we have in our hand is to draw as many points as possible and then join them, okay, with whatever means the way you try to join them. Okay, join them by a smooth curve. Fine. Maybe I can give some examples over here. I don't know how the graph will look now. X cube minus, oh sorry, I'm sorry, minus x square plus x. Yes, so I don't know how that graph will look, but it's not going to be a straight line. Okay, fine, it is like this. Suppose I go for minus say 5x square. Okay, so now it looks like this. That's the nature of this. If you want, you can add say x raised to 4 over here and then minus x cube and so on. Okay, sorry. So this is the nature of that graph and so on. Just now I was talking about sine and cos, just try to recall that. So maybe we can get the graph of sine and cos also. This is just I'm trying to give you some idea. Okay, so sin x, the graph is like this. Similarly, if you go for cos x, let us use different color for cos, red color. Okay, and then the graph of cos is like this. If you want, because we talked about 2 raised to x and 3 raised to x also. Okay, so let us say 2 raised to x. Let us use another color for this, say green. Okay, then it is like this. Let me stretch it below, take it below. Okay, and then there are several functions like log xa and so many. Okay, so this is how you can see that these are various graphs that I have tried to give. Okay, do this. Means the process is same. Try to get as many points as possible and join them by a curve. Okay, what I suggest, what I would like to suggest to you is that you better use this online this graphing tools also. They are available. If you Google it, you will find out that you can substitute some information, so you will get a lot of ideas about all these graphs. Okay, so we have talked a lot about graphs. I am not going to now extend it further. In the next video, I will start with the idea of limit of a function.